Okay, we're back. Bio 221. This is going to be the second part of the Chapter 23 for Seeley's 10th edition A&P book. Alright, I went through in my last video just an overview of some of the basics, how the respiratory system is put together, and I want to draw our attention back to the book just to make sure you are paying attention to the book, because that's where all the important stuff is that I'm going to gazing over in my little mini lectures here. So the pictures are going to show you all of the what. And again, on tests and quizzes in this class, I'm not giving you diagrams, but I am asking you about functions, so you do need to be familiar with those things. I think for anatomy, obviously in the lab, you'll have lab practicals where you have to know these things, and studying the pictures and the models is very, very helpful. In terms of the level of detail that you need to know for the anatomy, you need to know all of it. None of it is irrelevant. I'm just gazing through it real quick. It all plays a role, and you should be familiar with all of it. As we move through the chapter, I'm now on page 818. You'll see, this is important actually, kind of a cross section of the trachea. And if you think about where the trachea is in the neck, it's actually anterior, so you can kind of feel it. Not really. Your thyroid is kind of in the way there, but your trachea would be right in there. And if you've ever watched those medical dramas, they can, like, you know, resuscitate people by, like, sticking a pin in there and breathing into the pin or whatever. And that's because your trachea is right there. If you can just get that pen or that sharp object in between the tracheal cartilages, that in theory could work, unless you puncture the carotid artery and then you're out of luck. Behind the trachea is the esophagus. So think about that. When you're swallowing something that's big, like you just took a bite of a cheeseburger and you didn't chew it all the way and you go to swallow it, what you're actually doing is you're squeezing air out of your trachea when you do that. And the trachea, I'm going to scoot this back so you can see I talk with my hands a lot, so that you can see and really visualize how the trachea is put together. And it kind of shows you there on page 818. The tracheal cartilages are actually C-shaped, and the esophagus goes behind that. See, C-shaped cartilages, esophagus right here. So as that big food is coming through the esophagus, well, it can kind of squeeze some of that real estate, you know, some of that space out of the trachea. If the trachea had closed circle, my wrist was broken. I'll just do it like this. If the tracheal cartilage were a closed circle and the esophagus were a closed circle, there would be no way for the large pieces of food to get down. They would get stuck, and we would end up choking half the time. So it's kind of a good thing that our tracheal cartilages are C-shaped, and that's what's showing you there. It's also showing you a little bit of that. One of my favorite terms, the mucus escalator in the trachea. It's just this, all of that ciliated columnar epithelium just always beating in an upward motion to get that junk out of your respiratory tract. If you work in a very polluted environment, or an environment where there's lots of little things that you breathe in, it's highly likely that you are producing lots of phlegm and coughing up stuff occasionally. My father actually worked at McCormick's, the spice company, and he was in the like machine area where they would actually like bottle up all the spices, and he worked there all throughout my growing up. I rarely tell side stories. This is relevant, I promise. He would come home and he would literally smell like, I'd be like, hey Dad, did you make taco seasoning today? He would smell like taco seasoning. Hey Dad, did you do basil today? You know, he would smell like that because it was all in the air where he was working. And now he's going to be 60 this year. Ooh. But he now has a terrible chronic cough. He's actually on disability because of all the particulates that he breathed in during his 20 years of working there. He's actually had MRIs and X-rays where you look into his lungs, and he's breathed in so much junk from working there, and I mean working other places too, and I'm sure he smoked back in the day too, whatever. But his lungs are just perforated with little white things on the X-ray, which I don't know what those are, but it can't be good. It's not cancer or anything, because cancer would be like localized in one spot. This is just everywhere. It's just showing how he just inhaled all of this stuff year after year. So it does, affect you, especially later in life if it's not affecting you already. Okay, and let's see, some other anatomy pieces. On page 821 you see what I was talking about with the terminal bronchioles branching off into the alveoli sacs, and then you see that close, intimate relationship between the circulatory system and the respiratory system. We call the two of them together the cardiovascular system, right? It's the heart and the lungs together. And you see how that venous, how those capillaries are really just wrapped right around those little teeny tiny alveoli to allow for that gas exchange to take place there. And that is probably the biggest point. And then you actually understanding the anatomy of the respiratory membrane. The respiratory membrane is what we call that inner part of the alveoli. And there's actually three parts to it. There's the simple squamous layer of the alveoli itself. And then you have this endothelial kind of basement membrane, which is then fused to the actual circulatory capillary. So it's kind of like a little peanut butter and jelly sandwich, if you will. You have the side of the alveoli, this basement membrane, which is like the jelly or peanut butter holding it together, and then you have the side of the capillary. So it's this kind of tri-membrane structure, and so when gases need to exchange, they need to go through all three layers to get to wherever it is, you know, in or out, wherever it needs to go. So, and obviously the pores at this layer are very, very small. They're continuous capillaries, only allowing for air, gases to be exchanged. So this isn't a site for protein exchange or anything like that, like we may have mentioned in the past when we were talking about different types of capillaries. Understanding the anatomy of the lungs, that's very, very straightforward, the fissures, the lobes, etc. And then we'll get into how we breathe and the mechanics of that in the next video. There's one last thing I want to cover, and that is, it's in here, I just think I missed it, the actual circulation to the lungs. So just like the heart has coronary arteries going to it and feeding the cardiac muscle cells, so does the lung. And it all branches off of the thoracic aorta. So the thoracic aorta has branches, which are called the bronchial arteries, and those bronchial arteries take blood to the conducting system of the lungs, and then that feeds right back into the pulmonary veins. And of course the pulmonary veins are dumping back into the left atrium. So, so in that way, the highly oxygenated blood that's coming from the pulmonary circulation, right, leaving the lungs and going back to the heart, it's kind of polluted almost with that low oxygen blood from the actual lung tissue. So only by like 2%. It's not a huge, you know, major deduction in oxygen concentration, but it does dilute the blood just a little bit. And that's an important concept when we get into partial pressures, which is going to be in my next video. So another little quick overview of anatomy and the respiratory membrane, and then we're going to jump into part 3, which is how we breathe, in the next video. See ya.